Hi Nitesh. Hi Subodhip.
Hi,
Hi,
Praveen.
Praveen.
Do you hear the sound of fan? So let's.
No, it's clear.
No.
It's okay.
Yes. Can you
Okay.
increase the font little bit? I'm using the mobile phone.
Yeah, I'll do that.
Thank you.
Is this okay now?
Yes. Thanks.
Okay.
I could not go do the assignment. I'll do it tomorrow.
Your voice is very low.
I could not do the assignment. I'll do it tomorrow.
Okay.
Yeah, same for me also.
Okay. Let other two come. Atharv and Vasant. So Subodhip, I forgot. Where do you work?
Yeah, I work for Honeywell.
Anyway, where is the office? Managatta Road.
Belandur. No, Belandur.
Belandur only. And where do you stay?
Indiranagar.
Indranagar. Okay.
You?
I stay in Belandur only.
Okay. Belandur where?
Belandur near Sarjapur Signal.
Okay.
Yeah. Okay. So let me just ping Vasant to join now.
Hello.
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 Yes. I can hear you.
Hi, Atharv.
Okay. So Atharv, neither Nitesh nor Subhadeep has done the assignment. What about you? Atharv, did you try the assignment? Okay, I
You
can't.
please go to the chat box. Can you hear me? Atharv. Atharv, your voice is not audible.
No, Atharv, we can't hear you.
Hello.
Yes. Yes, Atharv. Can you speak now? Atharv, you're not audible. Can't hear you. Okay, so now Vasant is here, and Atharv is having some issue. Atharv, you can try speaking or try writing in the chat something. What do you want to say? Else I'll have to start without you. No, Atharv, we can't hear you. No, I don't think anyone is able to hear you. Okay, you're not able to hear us as well. Yeah, do it fast. Vasant, did you try the assignment? Atharv, can you hear us?
Yes.
Okay. Okay, shall I start? Shall we start now?
Now, can you give me just 1 minute?
Okay.
Okay.
Hello.
Yeah, just give me just 1 minute. I'll come back.
Hello.
Yes.
Okay. You can hear me, right?
Yes, I can hear you.
Okay.
Okay. So, sir, did you try the assignment?
No.
Okay. So 24 hours of time is not good enough. So from now onwards, we'll have 42 hours of gap so that you can try the assignment.
Sure.
Anyways, now we are waiting for Vasant. We can discuss the assignment by the way. So the assignment was implement queue using fixed size array. We had already done that for a dynamic size, the very big size array. We don't care about the size. And then we just had to write the same code for a fixed size array. Then the second question was merge to sorted array, which is why we needed this because we wanted to learn about the merge sort. Hence, we wanted to do this question. This is a standard question. Even if there is no merge sort algorithm we want to discuss, we could have done this as a question only. I have listed this in today's list of questions. As you suggested me, that like we'll discuss. I have listed lots of questions for today. Let's see how much we can do, and rest I'll give as assignment. So you'll have lots of assignment for you for next 48 hours. So Vasant, shall we start? He's not here. So the third assignment was rotate 2D array. Again, we had discussed the code, I guess. Or did we? Did we discuss rotate 2D array? No.
No.
Okay. Okay. Confused between this batch and there's one more batch. Okay. So today we'll be mostly doing lots of questions on string and array. Some of those questions will need our using the stack or queue as well. Although they're not direct, straightforward stack question, they're not straightforward queue question. But the solution of these questions, which I've just listed down, is they will need the use of stack and array queue sometime. But there again from the list which Atharv gave, and also I didn't like that list, so I had my own list of questions as well. Okay, so let's start. Vasant, I'm starting. Vasant, you there?
Praveen, one thing.
Yes.
Yeah. So if when you are giving assignment, if you can give the input output as well, that will be more helpful.
Okay, I'll do that. I'll do that from now onwards. Vasant, shall we start?
Yes. You can start.
Okay, let's begin the question. So as I said, we'll do lots of questions. The first question today is, given an input string, you just have to reverse the string word by word. Okay. So if the string is if this is the input, then the output should be
Too much background noise.
okay. So this is the input. My name is Praveen, and the output should be Praveen is name my. You want to try? All of you, just think, and then if you have a solution, raise your hand or write something in the chat. Okay. Very simple question, straightforward, no brain in understanding the question at least.
So I think what we can do here, just split based on the space. Okay. Once we split it, then
So split based on the space.
okay.
And
Once we split it, then we need to iterate from the end. Like we need to take the count. Like
Yes.
once I split it, I get to know that it has totally 4 words, 1, 2, 3, 4. Then I need to iterate from the ending, like from 4, 3, 2, 1, like that.
Okay, Vasant. Yes, that is the solution which will work. Now, the next constraint here is you cannot use extra space. If you are splitting, you need an array to store these. You cannot use auxiliary space, extra space. Do it in order of one space. Okay.
If we can reverse the each word of the string in place, like my will be ym and
Okay.
name
Okay.
will be
Okay.
NA, then we'll reverse the whole string.
Okay. So, can you just whatever you said? Can you tell me in terms of code what should I write? I have
Yes.
okay. Just wait a second. So let me write. We are writing reverse word and the input is string and we want to implement. So what should I write here? So I have my string. Suppose the length of string is yes. What should I write?
Yeah, so my I have to take the first the beginning that will be like from the like it will be like m will be the beginning. I have to declare one beginning variable.
What come again?
So first I need to take one input.
Okay.
Correct.
What is the input?
That will be like that first element of the string, like character first element equal to str.
Equal to
Str of 0.
okay. Now
Now should be like recursively we can do.
okay. So Subhadeep, whatever you said is a correct solution. Just try to write the code. Meanwhile, I'll discuss with other if they got the solution. Okay. Just try to write whatever you said. You are on the correct path. So others, did you get what Subhadeep's suggested solution?
Yes.
Okay, so he's suggesting what we'll do is we'll just reverse the word first. So my will become ym, name will become eman, and is will become si, and Praveen will become nwevarp. So once we are done with that, we'll just reverse full string once again, and when we do that, we'll get our output. Okay, so good approach, good thought process. But now comes the code writing part. So both of you doing that. You people also, if you have got the solution, just try to write the Sudoku as fast as possible. Even I'll be doing the same thing, writing the code only. What solution I gave. Okay, let's see who does the first. Okay, I have done. So if you have done, just write something in the chat. If you have not done anything, then you can go through my solution. Okay, so let me explain the solution. So what I'm doing is I'm going through each character of the string. Okay, and first of all, I want to reverse only each word. I don't want to reverse full string. I just want to reverse each word. So I go from, so I take the first string and I just wait for the space. The moment I find space, this part, okay, this part is like for j equal to I, and then j less than n, and I is not, again, this is wrong. This is not I, this should be str of j. Okay, so this str of j not equal to space. Till that point I keep on going, and the moment I find a space, I just stop there and reverse. Okay, so do you get this? We are going each one by one, we are checking each character. The moment I find a space, this means we have found our first word, and then just reverse the string from I to j. This means let's try to do this for our current input. So for I equal to 0, we'll start from 0, and then j equal to 0 till j equal to 1, my, nothing will happen, my space. The moment I find a space, my I will be 0 and j will be, that point it will be 2. So I just have to, so what I'll do, I'll reverse my full string, but only from I to j. Only from, there's other method called string. We have to implement this as well. We have to implement this also, but I'm just assuming we have a method which what it does, given a string and start index and the end index, it reverses that string completely. That's why I have just written here reverse my string from I to j, index I to j, and after that we will come out of this. Actually, we have to increase our I as well.
And it should be j minus 1, right? Or it is j?
Depends how I have implemented this reverse. If my this implementation of reverse a string start to end assumes that the end is not the last index but last index plus 1.
Okay.
Depends on implementation. So if I'm assuming this first end is the index of the so suppose A, B, C, D, and reversing this, I am reversing from 0 to 3 or 0 to 4, depends on implementation of this. Okay, so again, I'm just saying we do not worry about edge cases. It all depends while the implementation. We just have to understand what we want to do. So if I want to implement this end as, so should I treat in this case end equal to 3 or end equal to 4? That depends. So the way I implement. Let's not try to implement this. Once we have implemented this reverse, we should be able to understand this the main method completely. So now your question has been changed. The simple question is reverse a string. Reverse a string str whose first character is that start index, and the last character we're talking about the end index. Okay, so we want to reverse this string from 0 to 3 only. Okay, so we are assuming end is the where I'm just writing this clearly, clarifying where what is start. Start is the index of, okay, nothing. Both are start and end are integers. That's it. Integers between 0 and n, where n is the size. Okay. So yes, now I'm saying the end is the last index. Now how will you reverse? So the question is reverse a string. Yes.
Temp equals to start.
Come again, I didn't get you.
Temp equals to start equals to end, and at the end, end will be equal to temp.
Temp equal to
start. So we'll keep the start value in temp.
Okay, temp is equals to str of start. Just try to treat it.
Yes, yes.
Okay,
And then str of start equals to str of end.
okay. After that,
str of end equals to temp.
that's it.
Yes.
So before that, I have one doubt in the reverse one.
Yes.
So here, like after reverse recursion call, reverse strij, it is like I equal to j. I equal to j or I equal to j plus 1 because we are increasing, no? So,
Where? Here.
eh,
This.
That
yeah,
will be j plus 1.
Okay, let me just see it. So once we are, I think it will be I equal j plus 1.
Yes.
yeah. Fine.
Okay, so guys, so if you want, I can take care of all the edge cases. I just don't want to spend thinking time with those. That's why I don't think about it. I just want to go ahead with the normal solution. I don't want to think about edge cases. That's why I don't write it. Otherwise, I'll take care of that thing. Okay. Yes, come back. So reverse. Will this work? Is the reverse good enough?
While start less than end, that
Yeah.
will
So
be.
this is just. Yeah, this is just the one character reversing. We have to reverse this all the string, full string, not just so while. We have to write a while loop as well. We have to write some loop while start is less than end. Keep on doing this, and then just start plus plus and end minus minus. Okay.
Yeah.
Or you can directly do here str start plus plus equal to str end minus equal to temp.
The more you do those things, the more it becomes less readable, but very much clean
Okay.
code and all. These are the better way of programming. I just write a little bit lengthy code so that you understand. Okay.
Okay.
Otherwise, better you do it here only. Okay. So now that we have implemented our reverse, what I'm trying to say is, we just try to find first word. The moment we find first word, we just reverse from that word. And this reverse str from I to j is the reversing that word, and then we increment our I. We start again. So we start again. This should not be this should be just while I is less than n. Okay. Okay. Sorry, what happened? Yeah. So it was an easy question, very simple solution. Now someone will tell me the complexity so that we can move ahead. Who will tell me the time complexity of this solution? Subhadeep, what is the time complexity?
Order of n.
Order of n. Athar, what is the time complexity?
Yeah, order of n.
Nitesh?
It is not order of n. I guess it is n square.
N square.
Not sure, but definitely not order of n.
Okay. Why do you think it's not order of n?
Because first we are reversing a word twice. Like we are changing the position of character of a word twice.
Hmm. So
That's
yeah. So it's not about reversing twice. That's not the point. It is not order of n. It can be something different. So it will be. Let me write. Do you think it will be something order of number of? No, it won't unlog n. Number of words into number of words, we reverse the into,
Length of the string.
no, it will be out of n. You are right, Nitesh. I can prove that. Like, let me prove that to you. So, what we are doing is we are in the first. Forget about this. Forget about this reversing. So, in this loop, we just go from 0 to j. First of all, we go from 0 to 2 and reverse the string. So that reversal, one loop which went from 0 to, so it will be 2 plus 2, and then, okay, some noise is coming. Okay, so I'm assuming it's my. So my name is Praveen. In that case, as example taking. My name is Praveen. I'm taking this example. So we'll take 2 loops to reach the space, and then 2 more loops to reverse. And after that, I'll take 4 loops to reach name and NAME, and then 4 loops to reverse, or 4 by 2, whatever. And then I'll go ahead. I'll take again two loops to reach is, and then 2 loops to reverse is. So at the end, so total number of loop plus number reversal, it will be equal to 2 into size of string only, and then one more reversal, one more size of string, one more loop for size of full reversal, size of string. So it will be equal to 3 into n. So it will be 3 of 3n. So it will be order of n only. Do you understand what I said, Nitesh?
Yeah, I got it little bit.
So it will be 3 of n. It will be 3 of n, which is equal to, which reduces to order of n only.
Okay.
So there are 2 loops. One loop is here. There is internal loop here. This gives a sense it might be n square, but no. And then one more inside here. This also gives you a sense of it might be n square, but no, because every time we're not doing it for each I. We are jumping our I every time we do this. We jump our I with j plus 1. Okay. So for every time we jump our I, we do 0 to I, and then again I to I some j, and then that j to some other j. So we just do the reversal for not for full string, but only for the part string. So at the end, the total number of loops are 3n. Hence, the complexity is order n. Okay.
Yes.
Praveen, here,
Clear?
how it can be 3n? Can you come again on second? Can you come? How it can be 3n?
Okay.
Yes.
So let's move to the next question.
Praveen, can you hear me?
Yes. Who is speaking?
Yeah, Vasant. Can you come again? How it will be 3n? Just
Your voice is breaking a little bit. Can you repeat?
yeah. Can you show me how it can be 3n?
Yes. So let
How
me
it is
repeat once
3?
again. Yeah. I'll repeat then. So, if you take this example, my name is Praveen. What we're doing is the most external loop while I is less than n, we are doing then j equal to I, where the inner loop starts from I. Yeah. Okay. So, okay. So, our external loop while I is less than n, we have one more loop inside for j equal to I to n. Okay. Until we find a space. So at the end, to reach our first space, how much time are we taking? We are increasing our, we start with I equal to 0, and then j equal to 1, j equal to 2. In 2 loops or 3 loops, we reach our first space. The moment we reach our first space, which took only three loops, we had to do the first reversal. The first reverse from I to j. So this reverse,
Hello.
Hello.
I think Praveen left.
Yes, looks like. Nitesh, can you hear me?
Yes, we can gossip, I think.
Okay.
Yes, Vasant.
Yeah.
How are you?
You're doing good, man. How are you?
Yeah, I'm also good.
Are you in Bangalore or what?
Yes, Bangalore.
Okay.
How is it? How is the work going? Are you working somewhere?
Yeah, yeah, working and everything is good. Mm. What about you?
Yeah, same, no change.
Okay. Yeah, now you joined, I think.
Yeah.
Hello.
Yes,
Yes,
Praveen.
Praveen.
Yeah, sorry. I think something happened from my side. Um, okay. So where were we? We were calculating the time complexity, and what I was saying, before we find the time complexity of this main method, just talk about the time complexity of this method. What is the time complexity of reverse a string, start to end? The time complexity of this is end minus start. Do you agree, Vasant? Here, the time complexity of this is end minus start, which is if you're doing from for the full string, it is order of n. Okay,
Yes.
order of size of the word or the size of the string. Okay, so now that we have
Okay.
the time, now that we have the time complexity of reversing a string, full string or full word, whatever, we know that, and that thing is getting called for each word. That's the only loop where at the end the loops are to make sure that we reverse each word. Whatever loop we have written, that is only to reverse each word, and then the time to reach that word. Okay, and there are two things. One, first find that word. Okay, first find that word, which is this loop finding the, and which is like we take to find that word is the first space, second space, third space. We are finding each word. So finding first word will take 3 loops. Finding second word, which is name, will take 5 more loops. Finding is will take 3 more loops. Finding Praveen will take some x 7 8 more loops. At the end, total number of loops to find each word is order of n. So this is total order of n, and then reversing each word is reverse first word 2 loops, reverse second word 4 loops, reverse third word 2 loops, reverse Praveen is like 8 loops or 7 loops, 8 loops. Total number of loops for this also is summation of the number of characters, and this also summation of number of characters. At the end, this is order of n, and this also all the reverse we have called is also order of n. So total is order of n plus order of n, order of 2n, and then after we have reversed all the words. After we have reversed all the words, we do one more reversal for full string, which is again n. So that's why it is 3n. Vasant, did you get this? Shall I repeat once again?
I got it.
So finding, it's like mix. It's not like nested loop, simple nested loop. It's like we just do some part to find the word, and then that's repeat. We just reverse that part. Okay, so it's like reversing each word. So if it ignore that part, how much time did it take to find? So we are reversing each word. First word reversal is taken 2 times. Second word reversal is taken 3 times. That's how we are summing up all the reversal. And one addition is this finding the word, which is again we are just looping through one full from I equal to 0 to I equal to n, and that is order of n. Okay, so you have to see the code. That's the only way to understand the time complexity. You have to see the code and how it is how j is incrementing, how I is incrementing. We are not repeating I and j ever. So what happens if if j reaches the first space, we increment I as well. So it's not like we are repeating some j for some I twice. One I and one j happens only once. It's not like I equal to 1, then j equal to 1, j equal to 2, j equal to 3, j equal to 4. This does not happen. If that would have happened, then the complexity might increase. If for single I equal to, suppose I equal to 2, we are doing for j equal to 1, j equal to 2, j equal to 3, j equal to 4. in that case, that complexity might be different. The complexity might be n square. But if you see this clearly, if you try to see this focus, what happens is we're not repeating anything for single I. If we are doing single I and a single j, the moment we j refines the first space, even I changes to that place. Okay, so we have done a very simple question. We have also found the time complexity without any extra space. So space complexity is order of 1, constant space, no auxiliary space.
Praveen, here I have one question.
Yes. Yes.
You added while loop in reverse word, right? In that definition, you added while loop, and I is incrementing I equals to j plus 1. So if I replace while loop with for loop, does it work?
So if you replace while loop with for loop, does that work? So for loop, you write I plus plus and you do one more I equal to j plus 1. So the last I equal to j plus will override your I plus plus. Okay, so it will work. Depending if you do any previous thing, like okay, that place you're doing I plus plus, and then suppose you end up doing I equal to j minus 1, suppose something like that, or I equal to some j minus 1, I minus 1, or suppose the j only was something very negative, then in that case it might be a problem. But here, since your for loop was making you incrementing by only 1 for I equal to 0 to I less than n and I plus plus, and then at the end of the loop you are doing I equal to j plus 1, then what will happen is simply I will be overriding that I plus plus and it will work. It won't be a failure according to my knowledge of loops. Yes, it won't be a problem.
Okay. Because I tried in C, it doesn't work for me. If I increment I inside and again, it doesn't work for me.
Okay, then let's try to code this after the class is over. We both will. I think because in Ruby language, what I think is if you override, it will override. It depends again language specific, but I think most all the language will be same in this term. If you increment some value of I inside the loop, it will end up overriding that. I think that let's try to prove this after the class over. Okay.
Okay.
Shall we move to the next question?
Yes.
Okay. So you have your next question. Evaluate postfix mathematical operation. Okay, what is postfix mathematical expression? There is suppose 1, and then second element is suppose 2, and then third element is suppose plus, and then fourth element is 3, and then suppose last element is multiply. So this should be evaluated something like this: 1 plus 2 into 3. So what is happening is normally our mathematical expression or any expression is like infix. There's something called prefix, there's something called postfix, and then infix. Normally expressions are like this only: 1 plus 2, then plus will be in between 1 and 2, and rest of them into 3, then into is between these two. So we understand what to add and what to multiply. But this is a different kind of expression where your first in expression there is something called operator. This is operator, and I think these are called operand or what, I don't remember. So these two things, 1 and 2, are the operator between those 1 and 2 is plus, and the operator between the result of this and 3 is into. This is how a mathematical expression look like in postfix postfix way. So why we call it postfix? Because the operator is after both the operand. I'm assuming the word is operand. So the operator is after so first operand, second operand, and third operator. So and we assume how to use that operator to perform our whatever plus or multiplication or subtraction. But the operator will be after the operands. Okay. So you have been given a mathematical expression which is like this in an array. Suppose each element is either a operand or an operator, and the operator will always come after the operand. So you have to calculate this value, and so the value of this input, the output should be 1 plus 2 to 3, and it should be 9. Everyone, you get the question?
Yeah, got it. But
Yes.
how?
Can you give another example?
Another example?
Like a bigger one.
Okay. Let's try to give you a bigger one. So let me just try this in. So 1, 2, 3, 3. So this will look like 1, 2, and these two have to come. So this will be plus, and then we have 3, 4, and then one more plus, and then multiplication into one.
We can solve this by stack.
Wait, just wait a second. So this is the one more example. This is one more example. I think this is wrong. Just let me think. Let me just think once. So, is this a correct example or not? 1 plus 2, and then 3 plus 4. Yeah. So this looks to be correct to me. So this is another big example. Whoever was asking, for example, this is an example. Now you can think about solution, and meanwhile Nitesh will ping me solution in private. Nitesh,
I did not write the code actually. I'll try to write a pseudocode and give you.
Yeah, you take your time and write a pseudocode. Meanwhile, others will also think. And if anyone has any question, if you do not understand the examples, ask me. If you understand, just go ahead and try to solve.
So Praveen, in the array, that is the input, correct?
Yes, this array is the input. Yes.
Okay, and that 9 will be the output after counting whatever
Yes.
it is.
Yes, 9 is the output. Yes.
So can we do like this? Like we'll take the stack.
We'll take what?
We'll take the stack.
Stack. Okay.
We'll push 1.
Okay.
We'll push 2.
Okay.
And when we will get one of the operator,
Okay.
we will pop 1 and 2 and use that operator.
Okay.
And then we will store that value.
Okay.
Then we will push 3.
Okay.
So we have one stored value. We will get new operator. So the stored value will with new operator will be multiplied with 3. Like we will pop the 3 also at that time.
Okay. 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 So Subhadeep, Nitesh, I think you were also saying you will use a stack. I hope your solution was also similar.
Yeah, similar.
Yes.
Okay. Vasant and Subhadeep, did you get what these people are trying?
Yes, I got it. Yeah, my question is after adding 1, 2, then we need to push it back to stack.
Yes.
Okay.
Okay. So this is again a simple
Hmm.
question. I would like someone to tell me what to write as code, and then we'll talk about time complexity as well. Who will tell me what to write?
Uh,
We need to initialize the stack first.
Just yeah.
let's
So let me
just
just
start.
write the method. Evaluate array first initialize our stack. Okay. Now what do we do?
Once stack dot push, we need to start iterating the array. Okay. Then we need to start pushing the element, each element, and we need to add one more condition whether that should be an integer, means the pushing element should be an integer.
Okay, try to talk in terms of code. Lots of English. I want to write
Okay.
code.
If a of I greater than equal to 0 or something.
Okay. Suppose there's a method. Okay.
Then we need to push that value.
If that is an operator, we do something else. If it is not operator, we just push.
Okay.
It will be
What do we do? What do we do if it is an operator? What do we do?
We need to pop the element, first element. Means any elements we need to pop from the top, like my stack dot pop, and then we need to second operator expression of. Okay, that is fine.
now we can take the switch case.
In the top we can initialize one more float variable or something, so yeah. Okay, that is also fine.
And the operator.
Okay.
Yes.
Okay. So at the end, we just what do we return?
The last element, pop element, we need to, or top or.
ठीक है? Everyone, this is simple. Try to write code. Try to write. Think in at least, if not writing in your mind as well, you think in terms of code. Okay, that will make lots of things clear. What you have to do. What you if you think just we will do this and we will do this, it will not make sense to either of us or to either of when you interview as well. If you try to talk in terms of this for loop, while loop, and if else, it will be easier than conveying things in terms of English. Okay. Okay. So complexity. What is time complexity?
This is O of n.
O of n. Anyone else?
O of n.
O of n. Subhadeep, what do you say?
O of n.
Okay, cool, nice. So I hope everyone get this. How it is order of n, and then we'll move to a next question. Okay, so I'll leave this for assignment. I'll go to the next question for given 2 words, start and end, and this also leave for this will do when we do BF and DFS. This will do when we learn about heap. Given a collection of intervals, merge all overlapping intervals. Okay, so this is a question. This is an array question. Okay, given a collection of intervals, we have to merge overlapping intervals. Okay, so let me write input. If you do not get the question easily, then input is one interval, second interval, third interval, interval like one to mute yourself if you're making these kind of noises. Okay, so we have this. We have 2 to 6, and then 7 to 9, and then 8 to 10, something like this. So the output will be merged intervals. So 1 and 3, and then 2 and 6 will become 1 and 6, 1 to 6, and then there is no merging. But the next merging is 7 to 9 and 8 to 10. These two can be merged to 7 to 10. Okay.
I didn't get 1, 2, 3, 2, 2, 6, 7, 8.
Yes, come again.
How it is happening? The output merge all overlapping intervals.
So merging intervals, it's like if you good. So suppose there's a meeting from 1 o'clock to 3 o'clock, and then other meeting from 2 to 6 o'clock, and then next meeting from 7 to 9, and last meeting is from 8 to 10. So the meeting number 1 to 3 and 2 to 6 are overlapping meetings, and they can be merged into single meeting like 1 to 6. And then next meeting is from 7 to 9. There's no meeting between 6 to 7. So 2 to 6 and 7 to 9 can't be merged. But 7 to 9 and 8 to 10, they're like overlapping meetings, so they can be merged. Okay? That's what merging means. Hence, we are merging 1 to 3 and 2 to 6 into single 1 to 6. We are removing 2 and 3. We're making it 1 to 6 directly. And second is 7 to 9 and 8 to 10. So they're here 8 to 9 is overlapping. So we'll merging this to 7 to 10. Okay?
Yeah, fine.
Okay. So just think again. You don't have to come up with any fancy solution. Just try to do it with as simple as like think and what you'll do in a brute force way. Just come up with that solution. Okay.
We can compare the first interval with the other intervals.
Okay.
If
We can change if in first interval if there is any missing number, is that number we can find in some other intervals.
I don't get. Come again.
So first interval is 1 and 3, right?
First interval has.
First interval is 1 and 3.
Okay.
So there is a missing number, right? 2.
Okay.
So if we find that 2 in some other intervals, that means there is some merging.
Okay. Suppose this was 1 to 5, and this was 6 to 8. This is something different. Now, what do you say? 1 to 5. There are lots of things missing in between 1 and 5. Do you think you will be able to merge 1 to 5 and 6 to 8?
It will not merge, right?
No, it will not merge.
It will merge because
Oh yes, 5 and 6. Okay.
What?
1 to 5.
Praveen, here output is 1, 5 and 6, 8, but it
Yeah.
doesn't merge, right?
Yeah, this doesn't merge. Yes. So
Yeah.
I'm just trying to contradict Atharv's point here, that there's something missing. Just try to find that, and then we'll find that somewhere and merge.
So the first two intervals are not merging, right?
What?
1 and 5 and 6 to 8.
Yeah, they're not merging. Also, so I'm not contradicting. I'm just thinking, will you still be finding that? Like, suppose 2 is missing, 3 is missing. What will you find? Will you find 2 everywhere? Will you find 3 everywhere? Will you find 4 everywhere? What will you do? How will you find everywhere?
I can give.
Try to check in all the intervals.
Okay.
And if it doesn't found, then we will not merge it.
Okay. So what will you find? Will you find 2, 3, 4, 5? Will you find each of them?
Actually, we don't have to.
Okay.
Yeah, I have one more solution. The solution is, it looks like a matrix. Okay, what we can do, it is like a 2 cross some 1, 2, 3, 4. I think 4 cross 2 matrix something. What we can do, like for each row and the last number. For example, 1, 5. Yeah, you can make it as matrix, so it is easy for us to find out. Okay, it is 4, 2 matrix. What we can do. In each row, the last digit we can compare with the first digit of each row. Whether it's, assume if it is a 5 greater than 6, I'm going to check. If that is the case, then I can merge these two. Here 5 is not greater than 6, so I'm not able to merge. Do the same thing. 8 compared with 17. It is, even 17 is greater, means 8 is less than 17. I am not able to merge. Do the same thing. 19 greater than 18, so I can able to merge. 17 and 20 I can merge. 17, 19, 18, 20 I can merge.
Okay. So, can you try writing code?
Yeah, I can write down.
Okay, so let's do this. We will not spend much time writing code for this. I will give another solution. I'm not another, but similar solution. You have to write this. This is again not a very tricky thing. Simple question. You don't have to apply fancy algorithm here. So, as Vasant is saying, we'll have to compare. By the way, we don't have to structure it this way in a 2D way. There's no need to
Praveen?
this way. Imagine, yes.
I'll tell my solution quickly.
Mm-hmm.
So what we will do in the first at 1 and 5, we'll find out what is the difference of 1 and 5. So we'll say range is 4 here, and then the difference between 1 and 6 is 5.
Okay.
So like this, we'll find out a range of each array and the difference between first starting point of first array and next array.
Okay.
Whenever the
Got it. So everyone, even Nitesh and Vasant, all solutions are almost similar. The only thing that difference is we have to decide whether to merge or not. Okay, that's the only point of decision, and that's the part of the code which you have to write, whether to merge or not. Because all these are intervals and next to each other, we just compare. Okay, interval first and interval second, both of them. Do we have to merge them or not? That's the only decision we have to take, and that's the part of the code I'm expecting from you guys. So you have to write that part of the code. Rest, everyone is thinking on the same lines only. We'll compare interval 1, interval 2. And will that stay as interval 1 and interval 2, or will that become interval 3 as like merged interval? And then move ahead, move ahead will be whether it will be I3 and I4, or it will be I2 or I3. Understand? So will it be I1, I2 merged, or will it be just I2 and the next I3? So that's what it's like. Everyone is thinking on the same line. Just the decision of whether to merge or not. That's what the trickier part or the code part is. I'll try to write once again. We have I1, we have interval I2, we have interval I3, and like this we have lots of intervals. Okay. So we just iterate to all these intervals, and we decide whether to merge I1 and I2 or not. If we have to merge, we just merge them into a merge interval, suppose I12, and then we do the same thing with I12 and I3, or with just I2 and I3. That's the decision we have to take. This decision, whether to merge or not, is the part of the code which you have to write and implement, and I'll see this in the next class. Okay? What will you do? So Nitesh gave a solution. He will try to find the difference and all. You can compare the values like Vasant said, or do any part. That's not a very difficult part of code. It's just like you have to do something like A of I, A of J, A of I, J, all those things. You just have to write simple lines of code. And I would like to see the solution in the next class. Okay?
Yes.
Everyone got this solution? You can implement it after the class.
So do we have to compare I12 or I2 with I3?
We have to compare I1, depends on that what. If we have merged, then I12 with I3. If we have not merged, then I2 with I3.
Okay.
Okay?
But it's not in a sorted order, right? So let's say I1 is not merging with I2. We need to check I1 with I3 also.
Okay, so there are two questions here. One, these intervals are already sorted. Okay, no, and other is when they're not sorted. So you have to do for both the cases. The thing I didn't say this not sorted or sorted because we'll anyways have to sort. Even if you these are unsorted, you'll end up sorting and then solving this. That's why I started with sorted only. Now
Okay.
this interesting part here is sorted. What do you mean by sorted? That's the most interesting part in this question. What do you mean by sorted? And that's what you need to implement. The comparator method you have to implement to sort, because sorting any array of objects in any language, there has to be a comparator defined. To sort something, there should be a inbuilt method called comparator which has to be implemented to sort them, whether 1.5 is before 6.8 or after 6. How do you decide that? Or 1.5 and 1.3, which is before. Okay, let's suppose there's one more interval. 1.3. So should 1.3 come before 1.5 or after 1.5? So that this method is the most important part. Implementing this method is the important part. Implementing the comparator method in Java. The people in Java, they know for anything like sorting, there must be a comparator already implemented. For Ruby people, we also have something called array.sortBy, and then in the sort by we can define our comparator method. Once you define we can sort using that comparator. So this implementation of the comparator is everything. How do we decide whether to merge 1.3 and 6.8? Depends on this comparator only. Okay.
Yeah, okay.
Yes.
Okay. So
Yeah, Praveen. Yeah, sorry. Here you mentioned I1, I2, I12 means what is that one? That is the difference between two, or what is that one? I didn't get.
this is merged I1 and I2. So if I1 was, so I'm just saying if I1 was 1.5 and I2 was suppose 3.8, then in that case we are by our logic we are saying that we have to merge these two. Okay, this logic we have to define later, but by our logic I'm saying we'll merge these two and this will become 1.8. This is what our I1 and I2 becomes I12. This is what I mean by this line. Okay, so if it was 1.538, it will become 1.8, and we'll try to now merge with I3. If suppose it was 1.3 and 5.8, we will not merge these two by our logic. Which logic you have to define? We will not merge these two, and then we'll end up merging I2 with I3, and we'll ignore I1. Okay.
Okay.
Yeah. So now this problem we I have given a collection of intervals, not necessarily sorted. Okay, not sorted. These are in random. So we have to define your sort. You'll sort or not, and if you sort, what is this comparator method which you'll use to sort? Okay, you have to define that comparator method as well. Okay, so someone will note this down, that this is an assignment. Anyways, I'll send you the mail. Next, Next question is, I'll do this later, the matching a pattern and string. So given a pattern and a string, we have to tell whether this string is this pattern or not. Okay, so we will also take one more we'll learn about a pattern matching algorithm called KMP, Knuth-Morris pattern algorithm. That point of time I'll cover this. I'm not covering this right now. We'll go ahead. Now next question is, given an array of integers, find two numbers such that they add up to a specific target number. Very simple question. You should be able to answer this in 1 minute, every one of you.
We can take two targets, two for loop and submit, and we can find out.
So when we know what is the sum, and we can pick first element and find the difference, and then if it is a sorted array, we can use binary search to sort that number.
And if it is not sorted,
then we'll have to iterate. Or if it is possible, we can sort it first.
okay. So tell me one thing. So if it is not sorted, you'll sort first, or what will do?
Either we can sort first, or we'll have to iterate through each element, because we know what is the target element.
Yes. So target element is 13. So what do? You first pick one, and then what do you do?
Okay, if the sum is 13, then we'll pick
Yes.
one and
Yes.
we'll subtract 1 from 13 and we'll look
Yes.
for 12.
Okay. So you do not find 12. What will you do after that?
Otherwise, what we can do, start from front and start from back. So just
Okay.
compare whether the summation is greater than or less than equal to greater than 13. If it is greater than 13, then decrement.
So again, this is not sorted.
Which it is a sorted one. It is a sorted one. Okay. If it is not sorted,
Then either you can sort and then
the best way is
you can sort it first.
We can sort
then
it. We can do it. If it is not sorted, then sort it first, and then we can iterate. Means we can use only one loop and start from the front and start from the back, like a while loop. I'm going to use only one while loop, and I will use two variables I and j. One is from the front and another one is for the back, and I will check the summation of these two whether greater than 13. Otherwise, increment I. If it is less than, if it is greater than, decrement the backside onwards. If it is summation is less, then increment from the front side. Like that I will do. Finally, I'll get the answer.
Okay. So I'll come to this solution, Vasant's solution. But before that, let me discuss Subodhip's solution, which is order n square and which is correct. Completely wrong. Sorry, this is complete good. This is order n square, and this is the most trivial approach, the brute force approach. Subodhip, now we wanted to, if you give me this solution, I would ask you to improve upon this. So Vasant's solution was the same improvement which we are discussing. And what is the complexity of solution which you gave, Vasant?
Now n log n, because here only the sorting takes time. Apart from that, one is while finding we can have n, while sorting it takes n log n. I'm going to use quick sort for sorting.
Correct. So let me just repeat what Vasant said. What he said, first of all, we'll sort it, and once sorted, we will try to find these two numbers. What we'll do, we'll start with two indexes, one from the beginning, another from the end, and we'll try to increase the starting index from left side and decrease the index from the back side. Okay, and that decision will be based upon the current sum. Let me just write some code for you, and before that, I'll mute you all. Okay, so we have, first of all, we do a dot sort. We sort our array, and after we have done with sorting, while start is less than last, start is equal to 0 and last 1 minus 1. Okay, while this is less than this, what we do is we take our A. So we are doing this on a sorted array. Okay, we have already sorted, which is order n log n. Now comes the after sorting, what we do is we just see if A of start plus A of last is equal to what we are looking for, target. Okay, can someone tell me what will the code
Start plus plus.
Start plus plus, and here
Last minus minus.
correct. Okay, so the complexity of this is order of log n, because this sorting only took order of log n, and this part was order of n. Hence, the total time complexity is order of n log n. Can we do even better than n log n?
We can.
Okay. Yes, Nitesh.
So we know that we have to. The target is 13.
Mm-hmm.
If we pick first element, we know that we need to find 12.
Yes.
Oh no! This
Otherwise, we can do it. Yeah, Praveen, we can do it, but we need to use some hash map, extra space. We can reduce to n.
Okay. Nitesh, can you do it without space?
I can do the space, but I think the time complexity will go n square. Because if we could not find the 12, then we'll have to go to the n we can do in some other approach.
Okay, so Vasant, you tell me what we'll do. Everyone giving one solution with me.
But here I'm going to use extra space. We can reduce to n, but the thing is we need to use hash map, extra space.
That's okay. That's okay. I'm okay with your extra space. Just tell me the order n solution.
Okay, first what I'm going to do, I'll take one for loop. Okay, one for loop and one hash map. First, initial means I'll create hash map. After that, next is for loop. And first I will. Okay, first what I'm going to do. First I will check target minus if condition. This is if condition. If target inside for loop, if target minus a of I means array of I, whether it is equal to means whether it is present in hash map, then just straightforward what I need to do, I need to return a of I as well as hash map dot get key. So, okay.
If this is present, then
yeah, just I need to return a of I and my hash dot hash key, whatever the get key bracket target minus I, something like or target minus I. The straight is target minus I. Target minus a of I. That is straightforward. You can remove everything and just put okay. Yeah, that's fine. Otherwise, if it is not found, then what I need to do, I need to push a of I into hash map. I think you need to push only AFI.
AFI.
Yeah.
Okay.
AFI, comma AFI. That is okay. That's
Right. The key is the value and value is the index. Okay, that's what we are storing. Or
Yeah.
has a, I'm showing as key is the value and index is this. Okay, key value pair. So this is order of n. Using an extra hash map, we can do it in order of n. Okay, Subhadeep, do you understand this solution as well? Subhadeep, any doubt with this? Atharv?
Yeah.
Sorry, I was in mute.
Yes, Subhadeep. So I'm asking, do you understand both the solution? Order n log n and order n both solution?
Yeah, I'm thinking another solution.
What?
I'm thinking another solution. Trying to think.
Okay.
Like if you do, so like the sum is 13, correct?
Okay.
So I'll square 13. Okay.
What?
I'll square 13. Mean 13 into 30 and find the square of the sum.
Okay.
That will be like 169, correct?
Okay.
And 169. And here like the output are 10 and 3. Okay.
Yes.
So it will be like 10 square plus 3 square plus 2 into 10 into 3. Means a plus b whole square formula.
Yes.
Then we'll find the c square. Like
why do you want to do these things? I don't understand. Why do you want to find a square and even complicate it? Like you have simple numbers. What is the benefit of doing squares?
Just thinking.
Okay. So do not try to think a lot, but do not try to deviate your thoughts in these random. Okay. Try to control. Otherwise, normally sometimes if you go into interview, you'll waste your time in thinking these things. There's no need of these things. Okay. Okay. We'll move ahead. That's okay. No, not a problem. But that's just a suggestion. Don't think in these ways. Okay. Yeah. So this was again easy question. I have more questions with me. This I'll give as assignment. Next is given a two sorted array. Merge them in sorted array. This question I had to give you for our merge sorting algorithm. We'll do this now, and then let's do one more is check for balanced parenthesis.
So ninth one is similar to the 8th one.
Similar to
the earlier one.
Wait, check for balanced parenthesis.
No, the ninth one. Ninth question.
Ninth is it is similar, but yeah, the time complexity it will be slightly higher than that. So that question you'll do it as an assignment. Okay. It is similar. Yes, it will use exactly same thing of our find the two numbers whose sum is this, whose sum is target. This is the sub problem of this bigger problem. This triplet is the bigger problem, and that's double element we have two elements we have to find is the sub problem. Okay. Yeah. So now we are doing this question. Check for balanced parenthesis. So you have been given an expression like this. Okay. And you have to tell whether this is balanced or not. And what do you mean by balanced? Like if for every open, we have a properly placed closing as well. So if we talk about this first one, we have open, one more open, then close, and then one open, then close, and then one more close. So this is a balanced one. This is true. Okay. This is also true. This is also true. There is no bracket is also true. But this is not a balanced parenthesis. Okay. This is false. Now coming this is also false. Sorry. This is true. This is balanced, but this is not balanced. We have open, then closed, then closed. We have closed everything. We are unnecessarily closing more. So this is false. So do you understand what is the question? So you have to tell, given a string which contains open parenthesis and close parenthesis only, whether this is balanced or not.
We'll use stack for this, right?
You will use stack.
Yes.
simply count the number of open and closed brackets.
Nitesh, your voice is too low. Can you speak a little louder or do something?
Yeah, what I'm saying, we can simply calculate the number of open brackets and number of closed. If it is equal, they are balanced.
Can someone prove him wrong?
With this
Yes.
set of inputs, it is correct. Might be other.
No, it is sometimes okay. We can prove that one is wrong. Yeah, if that is the case. See, if it is
Nitesh?
closed, it is one side.
The number of open
Yeah,
bracket
yeah.
and close bracket.
Yeah, it
Don't-
will not. Yes,
Yeah.
yes.
So interviews also don't hurry. You take your time and think. Okay.
Yes.
Go ahead now. So someone was telling me something apart from Nitesh. Who was telling stack and something?
So stack we will push when there is open brackets. And
Okay.
for every open bracket, if there is some closing bracket, we will pop those two.
Okay.
Then for let's say for first example, we will push two open brackets.
Okay.
Then there is a closing bracket. So the first, so closing bracket and the earlier open bracket we will pop. So in stack, there will be only one open bracket right now. Again, we will push the second opening bracket. And then when the closing bracket will be there, we will pop those two. So
Okay.
right now in stack, there is the first open bracket. We will
Okay.
push the last closing bracket, and we'll pop that. So when the stack is empty, in this case, we will return true. Otherwise, it will be false if there is like open or close bracket remaining in the stack.
Okay. Nice. Good work. So Subhadeep, did you understand what Athar just said?
Yeah, I'm trying to write the code.
Okay. Okay. So people try to write some pseudocode for this. Otherwise, I'll write in 1 minute. You have 2 minutes to write. Just write some the way I've been writing. Write some code and send me in the chat.
Praveen, this session is up to what time? Means when you are going to?
Till whatever time you want. Tell me.
Yeah, I have a meeting within next 7 minutes. So
Okay. We'll try to
Now-
wrap up by 12.
12. Okay. Yeah.
So someone has sent the code. Subhadeep, awesome. So while expression I, if I expression I equal to open bracket, then push. If expression I equal to close, then pop. If stack is equal to null, return true, else false, which is correct. One case you have missed, Subhadeep. Subhadeep, you have handled the case for for true, but there is one more case which you have not handled for false. It might be false before only, before even you come out of the loop, you might end up saying, oh no, it is not balanced. Do you get what I'm trying to say?
No.
Okay, I'll repeat.
If there are multiple like closing brackets,
Yeah.
and the count
So-
is not same.
Okay.
Yes. So you have just done for the full loop, and then after coming out of the loop, you are trying to check if it's null and null or not. If it's null, then it's true, otherwise false. But you have missed the case when you are you are only one open and lots of close. So one close, two close, through close. So the second close bracket you will try to pop, and there will be empty stack, and that time only you can tell okay, this is not a balance. You don't have to go through full loop. Okay.
How it will be empty stack? Like
Everyone, this is good enough. You don't have to write now. The Subhadeep solution you can just see and then. What? I didn't get. Come again. Sir? Hello.
Hello.
Yes.
Yeah. So I was saying how the stack will be empty. I think you said when the stack will be empty in the while loop itself. I think we need to keep the count of the closing brackets, right?
No. Wait. What about this? So,
Yeah, so we will push one.
so you have pushed. Okay. Now you
Yeah.
pop. The first time you get closing bracket, you pop that. Okay. So you
Yes.
have nothing in your stack. Now, if you try to push in that stack a closed bracket, it should fail. So
Right.
the moment you push in a empty, the moment you push a closed bracket, not a push, sorry. The moment you get a closed bracket and your stack is empty, this means your it's not balanced.
Right. Got it.
ठीक है.
So you mean to say that we need to add that if condition inside. If stack is null, then return true or false something.
Yeah, if a stack is if you find a closing bracket and your stack is empty, then it is you have just return there only, return false. That's it.
Okay.
Okay. So can someone tell me, can we do it without extra space? I don't want to use this extra space. I don't want to use a stack. Can you do it?
Recursion.
Okay.
We can keep the count of opening and closing bracket.
Yes, it's simple. Why do you use so much of complexity? So we can simply maintain a count. Now the intelligent thing about the count is we just it's not like the Nitesh said ki we'll keep a count and the number of
We'll
this
have
equal
to-
to
We'll
it's
have to
not
Uh,
keep
that.
count for opening and closing both.
Yes, the opening count should be always greater than closing count.
Yes, one more check. So at the end, opening should be equal to closing, and also we should maintain that number of opening at any point of time should be more than number of closing. Okay, that is also what we have to maintain. Okay. So we have number of open bracket n equal to n1 equal to number of open bracket, n2 equal to number of closed bracket, and we just scan through the array string, and we'll keep increment the counts, and we will maintain while this complete loop will just ensure that n1 is greater than equal to n2. Otherwise, the moment n1 becomes less than n2, will return false. Okay.
Yes.
Is that okay? Subhadeep, do you understand why we don't have to use a stack?
No. Actually, I was doing that one only.
Okay, you did that only. So then listen again. Okay, so what I was saying, I don't want to use a stack. I can do it without stack because this is a very simple question. We have our brackets, open bracket and close bracket. So what we do is we maintain the count of open bracket and count of close bracket every time. We will go to this for I equal to 0 to n. If a of I equal to open bracket, then n1 plus plus. If a of I equal to close bracket, then n2 plus plus. And then after doing that, we check if n1 is more than equal to n2, then go ahead, continue. Else, if n1 is less than n2, return false. And at the end, when we're done with the complete loop, we just check if n1 equal to n2, then return false, return true. If n1 is not equal to n2, then return false. Okay, this is same as your stack. In stack also you're doing same thing. It's just that you're pushing element and popping, and whenever you pop, you ensure that it's not empty, and whenever you push, you ensure that you just push nothing. You don't ensure anything. Okay.
Just count you are using.
Yeah, just the count. So the same thing. We don't have to use a stack in this case. I can complicate this question a little bit, and then you might have to use, because we don't know how many expressions are there in that kind of situation. In that case, you might have to use a stack and all. I'll give that as an assignment now. A difficult question, a difficult version of this only. Okay, I'll give a difficult version of same question.
So we can use switch in that case, right?
Switch. Yes, you. You
To
just
check
have
like
to-
different types of opening or closing brackets.
Yes, you can do that. Of course, you can do that. You can maintain n1, n2, n3, and n1 dash, n2 dash, n2, n3 dash. That like lots of brackets are there. Lots of different types of brackets are there. Then you can maintain count for each of them. So
Yes,
instead of maintaining count for so many of them, I will just have a stack in that case. I'll prefer having a stack. But yeah, depending upon whether I'm allowed to use a space, extra space or not, or whether I'm allowed to use extra variables or not, depending upon that. So I would not like to go for a maintaining n1 dash, n2 dash, n3 dash, and I would like to maintain a stack only. So that will be beneficial if you have lots of different types of brackets. Using a
again-
stack.
So let's say we are using stack here
Yes. Yes.
for the case you have written with different brackets like closing round bracket and square brackets.
Mm-hmm.
So in that case also we will have to check different kind of brackets, right? So it
Yes.
cannot happen, right? Round bracket will go with closing curly brace.
Okay. So I get your point, Athar, but let me give you this assignment only, and I think it will be very difficult to do with just maintain the count, and it will be much easier than with a stack. Not just because
Okay.
of those which case, but because of other reason as well.
Okay.
Just try to think what will the complexity be, what not time complexity, but how complex will it be to solve this using just the counts and not using a stack. Okay, try to solve this without stack as well and with stack wide as well, both. So my question is now, the other question is, you have a string with okay, let's three types of okay, combination of all these six. Okay, now you have to tell me whether it's balanced or not. Okay, this kind of string it is. There is one more example I think at the above. So this example, these are all three types of brackets: the square bracket, the parenthesis, and the curly bracket. We have all three of them. Okay, so try to solve for this also using stack or without using stack, and then we can discuss in the next class. So yeah, we have done lots of questions today. I will send you the assignments. We'll do some new. We'll try to solve new questions in the next class, mostly on stacks and things. Also, we'll cover linked list in the next class. Okay.
Okay. Thanks,
Okay,
bro.
Vasant, you can leave. If anyone else has any point, they will discuss.
Okay, thank you.
Yeah. So, anyone else? Any question? Any doubt? Any query?
So I have one question. So I was just thinking, whenever we use like we solve array questions, right? So we always say we will sort this array first.
Yes.
That way it will be easier to solve that question.
Yes.
So let's say somebody asks me in interview, and I will say I will sort that sort that array. So in that case, do I need to write that quick sort or something like? Do I need to implement that, or we can use like array dot sort
You
method?
can use array dot sort. So normally, what happens if the question is very complex? You will not worry about your sorting and all. Okay, you sort. Okay, I understand. What will the complexity be? You'll say I'll use quick sort. It will be order file login because the main problem is something else. But
Right.
sometimes when the main question only is very easy, the end. Okay, you'll solve this using sort. So tell me how will you sort? Tell me the sorting algorithm you'll use. Tell me write the code for that. But 95% of the time, no one cares about the word what sorting you'll use. If you just say I'll do a sort and I'll do a dot sort, they will agree. So only 5% time that the main question is not so complicated, and the sorting is much better to ask than the main question. Okay.
Okay.
Yeah, depends on the interviewer mostly again.
Yeah, because it will take a different time than what we are solving exactly, right?
Yeah. Yeah.
And one more question on time complexity. So we
Yes.
discuss. So it's very. It's not totally easy, but it's comparatively easy to if there is a for loop, right?
Yes.
We can directly say it's a log n
Yes.
times complexity. If there is a two for loops, then we can say okay, nested. It's a n square.
Okay.
But what happens when there is like log n or n? Yeah, log n. How we can quickly find this?
Log
This
n.
has, yeah.
The log n complexity is a little bit of mathematical knowledge there.
Okay.
What is log n? What value is log n? It's like we it's very easy for us to imagine what is n square and n cube. But when it comes to
Right.
log n, it's not so simple to imagine. But you have to understand what is log n is. Log n is mostly, again, we talk in terms of base 2. Okay. Whenever we talk about log n, we end up talking about base. Subhadeep, I'll go through your code once again before I let me explain this to him.
Yeah.
So,
No problem.
okay. So log n is, what is log n? If you try to imagine, is number of times it will take to reduce you to 1. Okay. I mean, we're reducing something to half every time. We are cutting a cake or a square into half every time, and whenever we cut it into half, how much time, how many cutting or how many loops, how many cycles it will take to reduce it to single. Suppose it is made up of suppose there is a grid or something. It is made up of small squares, and there are 16 squares of the same size. Okay, and we cut it into 8 squares, then we cut it into 4 squares, then we cut it into 2 squares, and then at the end 1 square. The moment we time reach 1, and that number of cuts is required to reach 1. That is what log n is. This number. So this you have to imagine in what kind of problems, while solving what kind of questions, we are reducing our problem by half and half. Every time we're reducing a problem, not just half. Sometimes it is we're reducing our problem by 1/10. So in that case as well, it will be log of n, but just the base will change. It will be log of n base 10. Sometimes that can also happen. So my point here is, whenever it comes to that, we are reducing our problem size from n to n by 2 or n by 10 or n by 5, and then we're just ignoring the rest of the part and we're just focusing on that part. Suppose we break our problem into 5 small parts, and then we ignore rest of the part. We just focus on n by 5th part or n by 2th part, and then we just solve that problem, and then that also ends up solving that n by 2th and ignoring the n by rest of the n 2th. In that case, the complexity would be log of n, depending upon mostly 99% of the time it will be log of n base to the 2 only. That's why we don't even say base 2. We just end up saying it will be log of n base 2. We don't talk about base 2. So most of the time what we do is we break our problem into 2 halves, and then we ignore the first 1 half, because we know we are very much sure that our solution lies in the only 1 half. The second half is of no use, and hence our problem has been in one step, in one loop. Our problem has been reduced to single half problem. In the second step, the problem will be reduced to 1 by 4th, and hence it will take log of n loops to reach to single size. And the single size, we know what the solution is, because suppose the binary search only, the moment we reach single cell of the array, we know that is the place where we can take this, and we don't have to have any more loops. So these kind of solution, again, you'll have to go through lots of questions like this. These kind of question where we break our problem into smaller problems and we ignore the rest of the problem. That is a place we can call it log of n.
So like if we say binary search, right? So we can directly imagine it. We are doing in half and half and half. So we can directly say log n. That's right.
Yes.
Okay, I understood now. I think I got the point. Whenever we will divide the problem, we will not loop through. It will be something log n.
Yes, and divide and ignore. Okay. If you're going to both of the problem, it won't be log n. If only if you're ignoring one of the problem, then only it will be log n. Okay, it can't be.
Yeah, because if we are going to both the part, then it will be we are traveling traversing like n times, right? So it will be n.
Yes.
But if we are ignoring, then it will be log n. Okay. Yeah,
Okay.
got it. Thank you.
Okay. Yes, Subhadeep, your solution is something I have to go through, matching both characters.
Yeah.
While expression I is equal to open, then push. Otherwise, if stack is equal to null, then false. Else matching brackets, then matching brackets expression of I, comma pop.
The popped stack element, which I am going to compare.
Okay.
That method is written down.
Yes, correct. This is okay. This is what we were talking about. Yes.
Okay.
Anything else? So I'll send you the assignments, whichever I told, with inputs and outputs, sample input and output. And as I said, we'll learn about more questions on stacks and queues now in the next class. Along with that, we'll learn about linked list. Okay. I'll be ending the meeting. If you have anything, just ask me now.
Yeah. One more question. Like, whenever in the interviewer will ask for, can you optimize the solution?
Mm-hmm.
So brute force approach somehow we can try, but whenever the interviewer asks that Shuri, can you give me the optimized solution? So how should we think? Like what will be the point that should strike into our
Okay.
mind?
Okay. I do not have a straightforward answer to this. This comes by your two things. One, I think I've talked about this in early classes as well. Same thing I'm repeating. This comes from few points. Is like one thing is I'm not using any spatial algorithm. So is there any spatial algorithm which will help me? Is there anything brute force approach is like anyone can do it, but I've learned so many algorithms. Can I apply any of those to improve? Or is there any other data system instead of storing my data, instead of storing my input which has been given? Suppose the input was given as array. Can I store that into a stack? Can I store that into somewhere else to make my operations fast? To make my insertion, deletion, update, can I store somewhere else? Or third thing is practice. Once you have done lots of practice of questions, you'll be able to compare each question with some other question, and you will be able to remember the solution of that question. Hence, you'll try to draw a solution from that only. Most of the times, you'll be able to do it. And if you're not able to think, like correlate with some other problem, the only thing that remains is you have to whether use some other data system which is more like useful in that case, or some algorithm which I'm not able to imply here. Can I use something else? But there's no straightforward answer to this. And then again, it comes by practice only.
So,
Okay.
Hello.
Yes.
Yes. So I want to tell
Yes,
what
sir. Go ahead.
I want to tell what I understood with these 2 or 3 classes we had about how to approach the problem. So today we solved 2 problems, right? With one of the closing and opening braces, and there was another with so basically where we use each and every element and try to compare, we can use stack such like this. So Subodhit, you are you trying to understand this?
Yeah.
So there was an opening and closing brace, right? So we compare each opening brace with the closing brace, right? So that's why I thought it should be a stack problem. The same thing happened with the earlier problem where we were using that operator and numbers, right? So we will be pushing those numbers and we will compare with the next number, which next operator. So I thought we can use stack there. Or if there is a target given or something, then we can use hash map to easily use that. So that's my understanding. Maybe I'm correct. I'm not correct, but that's
no. If you're able to draw something, okay, why did we use this here? Then it's good enough. You're good. You should keep this thing in the mind, and so that you can relate this with other problems later.
Right.
This is good. Okay. If there are any thumb rules, I'll try to go through the. The thing is, I've never done this kind of. Okay, in this kind of question, we'll use this. All this has come up with lots of practice only, which is better than thumb rules. Thumb rules will not work in many places. Okay, so that's why I'm not giving any thumb rules. We'll do it after the end of all the lectures. Okay, now that we have learned everything, you're able to think yourself. I'll give you some thumb rules. Okay, if this is the case, you try to use this. If this is the case, try to use this. Those kind of thumb rules, I'll do it later. Okay, not now.
Yeah. Yes. Yeah. First, no problem.
Okay. Okay. Goodbye then. Good night to Indians and good morning to non-Indians. Bye.
Non-Indian?
Okay.
Okay. Yeah. Bye.
Sorry. Bye. Good night.